So there's another 10, 15 minutes just for any questions from the afternoon session. So for example, if any of the juniors members of the audience had a question they wanted to ask but didn't get to earlier, now's a great time. Or if anybody has been ruminating on the talks and now has questions, it's just open now for questions and discussion.
Any question online? I knew it.
I wrote it down, so I'll try to paraphrase. So I don't know if Roberta's still around. It was a really great talk, by the way. I was wondering what the role of potentially using prism spectroscopy as a component of the galactic plane survey would be in regards to looking for star formation indicators. Okay. Oh, Farmer. All right. Anyways, maybe she'll reply.
For Jesse about the all sky survey. Since the exposure times were relatively short, could you plausibly just say anytime someone pointed somewhere, you'd take a shot of your filter, and I wonder how much of the sky would you get by doing that by the end of the mission?
Yes, and I don't know. I think a really good, well, there's two things. I think the advantage of the all sky program is that it's very easy to schedule, right? You just between two slews, you take an image along the short field of view every time. The hard part there is the filters. As I understand, the filter wheel changes rather slowly. So that will introduce some overheads if you want to have a single band image of the entire sky. But that said, I'll take any all sky, right? So there is some design trade space there.
Great, thank you.
So sorry, Jesse, to pick on you, but so follow up to that. So thinking about the all-sky survey. So if we're going to really truly coordinate with Ruben, wouldn't you want some overlap? I mean, like I heard your answer right now, so you're right. Anything is good. Any photon's good photons. I get it. But if you were to optimize your survey, wouldn't you at least plan for some sort of partial overlap and then also then push redward? Do you see what I mean?
My guess is, so the white filter, right? If we go for the 146, it basically starts right after, the wideband stops. So my intuition is if we're pushing 2 magnitudes deeper than Rubin, then the likelihood of something dropping out between that 2 bands is unlikely. So it might not be worth staking another filter on that kind of reason. The other, really, I think the alternative and the right way to do this is take the whatever Roman all sky image is presented and then use that to do a force photometry on Rubin, because most likely the source deblending and the positioning of Roman is just going to be a lot better. So it won't be like a catalog level matching. I think it'll be a pixel level sort of joint reduction situation. Does that answer your question? Thank you.
Mike privileges here and keep Jesse on the spot. So a thought I had during your talk was globular clusters, and the infrared bands, the high resolution, especially when you pair with Rubin. I think that we have a chance of discovering like most of the globular clusters in the few megaparsecs of the local volume, basically.
I absolutely agree. Which is why I mentioned the sort of 10 megaparsec statistic as well. Like if a stellar population is out there, like you're gonna find it. So globular clusters, absolutely.
This is really a question for Jeff. So the missions that we talk about were designed to do all sky surveys from the start. Is there anything that you could think of that would prevent us from doing this or inhibit it? I mean, we can do it. So people quote the speed and the view and everything, but I'm wondering if there's something sort of lurking in there that would prevent us from doing it or make it just way more inefficient than people are estimating. Sorry, Jeff, for putting you on the spot.
No, the short answer is no. I can't see any reason why we wouldn't do it. You might not be able to do it in one continuous sweep of time just because of, we can only see 60% of the sky at a time, and that field of regard shifts a degree per day. So you might have to break it into pieces. That would be the biggest complication. Nope, not a bit.
So, sorry, Jesse, but another question. for you. So I liked your analogy of splitting the bill. You could also go Dutch and split the bill with Euclid, which has essentially the same resolution, invisible. Do you, and similar depth, and they're covering 15,000 square degrees or so. If you were doing that, would you go straight to covering the same area to get the proper motions, or would you?
In that scenario, it's actually the opposite. Would visit at the very last, so that the proper motion baseline is the longest. Of course, the cross survey calibration for astrometry is not solved problem yet, but it's unclear to me if that would be. Sorry, Slack. It is not. It is not super clear if that would be like functionally possible, but I view it as more of an opportunity. So like if Euclid has covered a third of the sky, that is an opportunity to learn more about that third of the sky than let's not go and image that part. Because just the cross-survey calibrations of photometry and astrometry and all that might be a nightmare. But it's an opportunity, certainly. And colors.
This is also for Jesse. So I'm curious what value you could bring for bright star science, like 10th magnitude, 12th magnitude.
I think those stars are going to be tricky as well, right? Because if it's actually too bright, then you saturate the pixels and then you're gone for 20 minutes. And that is not something I've thought too hard about. But we also know where the brightest stars in the infrared are, thanks to 2MASS and WISE. So if it comes down to having to avoid it, I think it'll be very easy to avoid it. In terms of what do we do to image it is, I'm not so sure about that. But maybe there's an angular resolution argument to be made there. I'm not certain. I was gonna ask that, but like it was an intrusive thought.
For Jesse or have announcements?
No announcement, so you can close it. You can close the session.
Okay, I guess that I'll close the session and I guess that's it. Thank you, everybody, for coming today. And let's thank all the speakers.